So in this video we want to look at rationalising the denominator of a fraction, or the bottom of a fraction. And generally when we're talking about surds, having surds in a fraction, we don't like surds on the denominator of any fraction, on the bottom of a fraction. And so what we do is we use a process called rationalising the denominator. And basically that says that if you have something, a fraction with a surd in the bottom, what we do is we multiply both the top of that fraction and the bottom of that fraction by the surd part. So if I have 1 over root a, then I multiply the top by root a and the bottom by root a. And so what happens is when we do this, 1 times root a gives me root a, but on the bottom of a fraction, root a times root a gives me a. And so we get rid of the square root on the bottom of the fraction, on the denominator. And you'll see if you do this in the calculator that the calculator will give you this answer automatically. It'll give you the rationalised or rationalise the denominator for you. But we need to know how to do that without a calculator as well. So imagine we have something like 1 over root 3. Well, the surd part of that is root 3. So what we're going to do is we're going to multiply the top and the bottom by root 3. So on the top, on the numerators, 1 times root 3 is just root 3. And on the bottom, root 3 times root 3 is 3. When we multiply a surd by itself, we just get rid of the square root sign. Let's try something like this. 3 over 2 root 5. Well, in this, we'll see that we have a surd in the bottom, so we want to rationalise the denominator. But the surd part is just root 5. I don't need to worry about the 2 for the moment. So what I'm going to do is I'm going to multiply the top and the bottom by root 5. And by multiplying both top and bottom by root 5, we're actually essentially multiplying by 1. So this is root 5 over root 5 is 1, root 3 over root 3 is 1, root a over root a is 1. So we're not changing the value of this fraction, just its appearance, how it looks. So when we do numerators, 3 times root 5 is 3 root 5. On the bottom, 2 times root 5 times root 5, well that's 2 times root 5 times root 5 gives you 5. And so overall we can simplify that as 3 root 5 over 10. And this is, each one of these, the denominator has been rationalised. So let's look at a few more just examples here. So first one, 3 over root 2. Well, the surd part is root 2, so we multiply top and bottom by root 2. And when we multiply the tops, 3 times root 2 is 3 root 2. And on the bottoms, the denominators, root 2 times root 2 is 2. For this second one, we've got 8 root 6. So I'm going to multiply top and bottom by root 6. So numerators, 8 times root 6 is just 8 root 6s, 8 root 6. And root 6 times root 6 is 6. And the only thing we need to be careful about here is just like any fraction, let's simplify it down if we can. And if you notice that 2 goes into the top line, which would leave me 4 root 6s, and 2 goes into the bottom line, which would leave me 3. Again, 7 over 3 root 5. We're going to do multiply top and bottom by root 5. I don't need to worry about the 3, just the root 5. And so when we do that, the numerators are 7 root 5. And on the bottoms, we have 3 times, well, root 5 times root 5 is 5. And so again, just simplify that. 7 root 5 over 15. For our fourth one here, then again, let's multiply by root 5 over root 5. So in the numerator, we get 15 root 5s. On the bottom's 2 times root 5 times root 5 is 5. So that's 15 root 5 over 10. And again, just look at this, we see that 15 and 10 have 5 in common. So we can take out a factor of 5 here and make that then 15 divided by 5 is 3. So that's 3 root 5 on top, and 10 divided by 5 is 2. And finally, this last wee example here, again, it doesn't matter what's on the top of the fraction, it's really just the surd and the bottom that we want to look at, that we want to get rid of. So here we're multiplying top and bottom by root 7 over root 7. Now, when I multiply 3 plus root 7 times root 7, well, 3 times root 7 is 3 root 7. Root 7 times root 7 is 7. So on top is 7. And on the bottom, root 7 times root 7 is 7. And we're just going to leave that like that. This won't simplify much anyway. One of the biggest mistakes, so just to watch out for, is people say, oh look, that 7 and that 7 will cancel out, and we get just 3 root 7 left over. Actually, that's completely untrue, because what we need to do is make sure that if we're dividing the top by 7, that every single term is divisible by 7, and 3 root 7 isn't. You can't divide it by 7, so we're just going to leave that as it is. Whereas in the previous one, 15 root 5 over 10, this is one term on top, 15 root 5. So 5 goes into 15 root 5 and 5 goes into 10. So we can divide through by 5 here. In this last example, we can't divide through by 7.